All right, y'all. Math Matters, back at it. I took some time out to get to TikTok, and uh, it's not going good here. Back to no job. Hopefully, this job will come through, but hasn't yet. It's getting tough out here on the yard, begging for money on TikTok. That's what you got to do. But I'm going to keep on going here. This Math Matters. This is for Algebra 2. I'm going to work with imaginary numbers, although it is very, very real out there. So, get ready, Algebra 2 students and those that like the subject. We're going to dive into the operations with imaginary numbers, this time on Math Matters. What's good, everybody? Ty the teacher, back at it. It's tough if I don't have a caller on, but we're going to get through this just to get another video up for the Algebra 2 camp. This will be the second one for each grade, and we're slowly trudging along. This standard is for students to be able to, SWBA2, students will be able to simplify, add, subtract, multiply, and divide complex numbers. So, to the board we go. And I'm trying to do you all a favor here and put the add and subtract together. All right? So, we can, as a matter of review, remember I, and that is 2 thick. We'll bring it down to 6. Remember that I is the square root of -1, which means that some number times itself equals -1. I give you some time to think about that and try to think of what that number is. What is that number that when you multiply it by itself, 2 times, the answer is -1? What could it be? What could it be? Well, it's not 1 because 1 times 1 is 1. It's not even -1 because -1 times -1 is 1. So that's why we use this symbol I right here. 2 of them, if you multiply it by itself, which is I to the second power, well, that equals -1. Okay? And that's all we're going to deal with right now, just 1 to the first power to the second power. So we're going to add these things together. We're going to leave this, we're going to have this multiplied by a number, and we're not going to do much to it in the add and subtract. But it's where we multiply and divide where we got to do a lot. Exclude the C word. That's coming up in division. So if we have like 5i plus 3i minus 6 plus 4i. Okay, what do we do here? Well, if we have the same variable, in this case the letter I, then we just add and subtract the coefficient. The coefficient is simply the number in front of the I. So in this case we have 5 plus 3, which is 8i, minus 4i. Minus 4i. That equals 4i. And we have this minus 6 right here. We just tack it on at the back. See, we don't add this in with this, this, and this because those have i's. This does not. So, try another one here. Let's go -3i plus 8 plus I minus 5. Okay, we have, let's do the numbers first, as we do the numbers here. 8 plus negative 5. That's 8 plus negative 5. We'll see minus, minus, which is plus, or plus minus, which is subtraction. So this equals 3. Now we have negative 3i plus negative 1i. So that's basically negative 3 minus 1. So if you borrowed $3, then you borrowed another dollar, then you borrowed $4. That's the number of i's you have. All right? 6i minus 5i squared plus 7i plus 7 minus 3 plus 4i squared minus 6i plus 7i squared minus 8. All right, a lot of them here. Let's color them up here and see about which is which here. So we have an I, we have an I, we have an I, and that's it. Okay. So let's do blue here. We have I squared, we have I squared, and we have I squared. And red and blue makes purple. So purple would be just this negative 8. And since this negative 8 is the only one there, that's going to be included in the answer. So after all those I terms, we'll do I to the second, and then I to the first. At the end, it'll be minus 8. So let's look at the I's first. We have 6 I's, plus 7 I's, minus 6 I's. So basically, this 6i and this minus 6i cancels out, leaving just the 7i. So we'll put that in front of the minus 8. Now, the I to the second powers. We have minus 5 plus 4 and plus 7. Well, these we can combine into 11, and then we'll subtract 5 from that, giving us 6i squared. This is what you get when you add that big old problem together. 6i squared plus 7i minus 8. If the term or the variable is the same, then you'll just add or subtract the coefficient. This 6, this negative 5, this 7, this, well, nope. Hey, wait a minute. That's a term. You almost got by me. We have negative 3 minus 8. So here's negative 3, and here's negative 8. That is a total of 11 negatives. I don't see that there. And this negative 3 is not a coefficient because it doesn't have a variable in front of it. So one more time. The coefficients are 6, negative 5, 7, 4, negative 6, and 7. These are the coefficients. That isn't a coefficient. This 7 is a coefficient. This negative 5 is a coefficient. And this 6 is a coefficient. Anyway, that's that. Now, multiplying. Multiplying, we've got to use our friend FOIL. Well, you know what? Let me do it vertically. FOIL. So we'll have something like 3i plus 8 times negative 5i plus 2. So the first, and you know what? I'm going to put these in different colors because I'm going to put a line with them. Let's go F O I and L. So FOIL is the first terms first. The O is for outer, which is those two, outer. Now the last two are the opposite of the first two. Opposite of outer is inner. So we will draw the inner ones, sides included. And the green is for last, opposite of first. These are the last terms in the two binomials there. Bi means two, nomial name. Both of these things have two terms in it. So, last, I didn't do the purple for inner. Let me get that real quick so you know what I'm talking about. Inner. Now, let's fade to black here and get on the multiply. So 3i times 5i, that equals 3i times negative 5i, sorry. That equals positive times negative is negative, 3 times 5 is 15, and we have two i's there. When we're multiplying, we just raise it to a power. We don't add the numbers in front of it because we're multiplying here. All right, that's the first. Now the outer is 3i times 2. That's write this number this many times and add. 3i plus 3i is 6i. All right? So 3i times 2 is 6i. Now the inner is 8 times negative 5i. Positive times negative is negative. 8 times 5 is 40. And there's just one I there. So that's just one I. And now last is something we all know. 8 times 2. That there is 16. Now these are the four numbers that are in the answer. The negative 15I squared has nothing else with it. And the 16 at the end has nothing with it. But these two can be combined, like we did in the addition and subtraction up at the beginning. They both have I terms, and we're adding and subtracting here. So we're going to add 6 and negative 40. Now, the difference between 40 and 6 is 34. But that's if you put the negative sign on the 6. If you put the negative sign on the 40, then it's not 34, it's negative 34. So we'll subtract 34i. This is what you get when you multiply 3i plus 8 times 5i minus 5i, negative 5i plus 2. Now, one more thing. This number can be changed because I squared is negative 1. Remember, I is the square root of negative 1. I squared is negative 1. So if we multiply negative 15 times negative 1, we get 15. Now, these two, this negative 34i has not changed. But now we have 15 plus 16. That equals 31. This is what you get when you combine 3i plus 8 times negative 5i plus 2. And yes, you will get two terms. The first term will be I squared. Remember, I squared equals negative 1. So you're going to basically change the sign on that and then add it to the constant term at the end. So that's multiplying. FOIL will do that, and you've done that in binomial multiplication just with the x on it, not necessarily I, but it's the same thing. All right. So with division, I'm going to write a fraction here because remember, every fraction is a division problem. And down here, we'll have an I, which is 4 times the square root of negative 1 plus 5. Well, remember, we cannot have this thing in the denominator, and that's what we have right there. So you have to multiply this thing times the conjugate of 4i minus 5, basically just the negative. So I'm going to do 4i plus 5 times 4i plus 5. And now we've basically just given up on dividing. This is basically straight multiplication here. So we've got 3i times 4i, that's 12i squared. That's going to be a negative 12 here in a minute. We've got 3i times 5, that's 15i. And we've got 8 times 4i, that's 32i. And at the end, we've got 8 times 5, that's 40. So we can combine these, and we can combine these. And when we do, we get 32 plus 15, which is 47. And we got 40 minus 12, which is 28. We usually put the variable first. So if you want to do 28i plus 47, that's just fine. 47 plus 28, that'll equal the same thing. And they're going to do the same thing down here with this. But something cool is going to happen when you do it down here because we have 4i times 4i, that's 16i squared, which we know will become negative 16. We got 4i times 5, which is 20i. And we have negative 5 times 4i, which is negative 20i. And we all should all know by now that anything minus itself is 0. 20i minus 20i, well, that's 0. And we have negative 5 times 5, which is negative 25. So we have two terms here, 20i and negative 20i. They're gone. So that leaves negative 16 and negative 25. Well, that equals negative 41. This is what you get when you divide 3i plus 8 by 4i minus 5. So whatever that number is, that's what you get when you divide 3i plus 8 by 4i plus 5. So there is adding, subtracting, multiplying, and dividing. Oh, and the simplifying part was where we took like terms and combined them. We combined those to get 0. We combined this negative 16 and negative 25 to get negative 41. That's simplifying them because you can't just have those sitting out there. Or here where we took 15i, and 32i. You can't have the answer with all those in it. You have to combine the coefficient. In this case, 15 and 32. Oh, oh no, that's just 47. I'm sorry. Uh, it is 47i. I'm sorry. 47i. 15i plus 32i is 47i. And then 40 minus 12 is 28. The I doesn't go there. It goes on the back. Sorry about that. There. See what I did, right? We had, up here we had negative 12 plus 15i. That was 3i times 5. 3i times 5 is 15i. And then we had 32i. That was 8 times 4i. 32i. And then we had 8 times 5, which is 40. Now, when we have the I squared, sorry. Well, I'm saying negative 12. Okay, so we had this 12i squared becomes negative 12. So we have 15i plus 32i, which is 47i. And then we had negative 12 plus 40, which is plus 28. We have 47i plus 28. And then we broke down this one. We had 20i minus 20i, which is 0. And we had negative 16 minus 25. And that's where we got the negative 41 from. That is it. All right. Look at it again. Just forgot to put the eyes on there. The math is sound. And so are my trips to the hospital. And that's why I have the visitor sticker on, because I got to go back. Hopefully, by the time I get back to you all here in Algebra 2, my plight will be much better. But see the visitor sticker? I've got to get back to the hospital, but I am torn between doing what I said I was going to do, which is drop videos, and actually taking care of my wife. So, went Sans caller this time. Try not to make that a habit. All apologies. But I'm in and out of the house and got to try to get things done here. Time waits for no one. Next time, hopefully things will be back to normal, and hopefully, and I see now, hopefully you do now as well, see that math matters. A lot of other things matter too, but math matters as well. So, till next time, you all take care.